Alrighty. So, it is Sup Bro Day, okay? Because we're going to talk about angle pairs today. So, we are in the new note packet that you should have picked up. Also got a new homework packet over there. We are combining Unit 6 and 7 into one test to make it be our worthy test instead of a 15-minute worthy test twice. And that test will be on Thursday the 26th. Okay? So that's that last week before spring break. On that Thursday is going to be the test, because on that Tuesday you've got pre-ACT and something else. There's some other one there. It's like a twofer. What? No, it's like pre-ACT and something else. Forward or something like that, maybe. I don't remember which one. But, yeah. No, sophomores take it to it, but, or, I don't know. It's something that day. But anyways, okay? So, today is going to be, there's going to be a lot of information thrown at you today, okay? All right? A lot of that information that I'm going to throw at you today, you've already known, or you've already learned. Okay, so it's going to be refreshing that information, hopefully drawing it back out, and then because we need to use it going forward. Okay, so with that, oops, double tap. With that being said, there is only two quick hitting problems. So quickly at the top, if you would reflect triangle HMS, and then find the perimeter of triangle HMS. So the slope of my line of reflection is going to be 1, which means then that the perpendicular slope to that is going to be -1. So I need to reflect on a slope of -1, so I'm always going to be working up 1 and right 1. Here's a up a half, right a half. So then over here would be H prime. Up 1 right, or excuse me, up 1 left 1, up 1 left 1 again gets me S prime. 1, 2, 3 to get to the line of reflection, which means I'm going to go 1, 2, 3 on the other side. And then I can connect those dots.
What did you do for H?
I went a half and a half. Went half to the line, half on the other side. Okay. Then it's asking us to find the perimeter of that. So I'm going to first find the length of my blue side here. I'm going to make a right triangle out of it. That's got a side length of 2 and a side length of 1. So then that would be the square root of 1 squared plus 2 squared. Which is going to be the square root of 5. Then I can find the side length, this green side length in here. That's got 1 and 3 for its side lengths. So that's going to be the square root of 1 squared plus 3 squared. 1 plus 9 is 10. And then lastly, I can find side HM, the pink side. It's got legs of 2 and 3. So that would be the square root of 2 squared plus 3 squared, which is going to be the square root of 4 plus 9, which is the square root of 13. Okay. On all of those, just so you are aware, I took the Pythagorean theorem, and I just took the square root on both sides right from the start, and then that gave me that the side length C that I was looking for was the square root of the the two sides, the sum of the two sides squared. So add them all together. Can I add them together nice and cleanly? Like, would it be the square root of 28? No? Okay. So what would it be then? Exact. No calculators. Could I go the square root of 5 plus the square root of 10 plus the square root of 13?
Yeah. Also,
Because that's the order that I went them in.
could you do like 2 square roots of 5 plus the square root of 2 plus
No.
the square root of
No, because the square root of 10 is not 2 square roots of 5.
No, I'm saying like 10, you can split it into 5.
Because it's still the square root of 2 times the square root of 10. Or excuse me, square root of 2 times the square root of 5.
Yeah, but couldn't you just have 2 square roots of 5 then?
No, because you've got the square root of 2 times the square root of 5 plus 1 square root of 5. You would have 1 plus square root of 2 times the square root of 5. Okay? Alright, so on this, I'm just going to talk more about what you see on this paper and not what you're observing and all that fun stuff. Put that away. We don't do homework during notes because then we don't know how to do our homework for the next thing. Okay? So, in geometry, in geometric figures and shapes and all that fun stuff, which you're going to see a lot in this unit, okay? There's a way to describe parts that are equal and congruent. Okay? And so if I'm dealing with a side length, then I'm dealing with these slashes. Okay? So if I put one slash through a side length on 2 separate figures, I am saying to somebody else that's seeing this, those 2 sides are equal in length, they're congruent in geometry. Okay? So I'm saying that side AB is congruent to side QR. This, by the way, is the symbol for congruent. It's an equal sign with a little wave above it. That means it's congruent. Remember, congruent is more than just equals. Okay? Congruent is equals and then some. We'll get to that here momentarily. Okay? In an angle, you've got a couple of different ways. So in an angle, you could have arcs going in between. Okay? And the same amount of arcs represents congruent angles. Because if you'll notice, you've got angle C and angle S have 3 arcs in it. Angle B and angle R have 2 arcs in it. So angle C is congruent to angle S. Angle B is congruent to angle R. Okay? Now, here's the other big thing, and I want you to write this down. Order of your letters matters. The ordering of your lettering matters. Okay? So when I say angle or side AB, I'm going from 1 arc to 2 arcs. That means that I got to go on my other figure. I've got to name it from 1 arc to 2 arcs. That's why it's QR. Okay? So what would side DA, what would that be congruent to? Side DA. What would it be congruent to in the other figure? No. It would have to be TQ because we went from one slash with one arc with a slash through it. That's T to A with just one slash. That's Q. Okay? If you put there QT, I will mark it wrong. Okay? Because order of your letters matters. I'll say that again for emphasis. If you put TQ, or if you put QT there, I will mark it wrong. Because order of your lettering matters. Okay? Any questions on that? All right. Let's talk some more. Okay? So if we've got a regular old triangle, okay? Triangle ABC, okay? This top angle up here, this top angle up there is angle A. And if I'm talking about
I was just going to ask, why did we use A and Q twice in the same, or twice in the last problem ago?
What do you mean?
Because we have TQ equals GA, then AB equals QR.
Because they're two different sides.
Why wouldn't we use ST then?
For which one?
Because you wrote A and Q twice, so I'm just wondering why we didn't use S and T and then C and B.
So side ST would be congruent to what side? Nope. CD.
Oh.
Because it went from the one with the blue arrow in it, right? Because we started with S. So the blue arrow was at C. And then we went to T. T had the slash, or the arc with the slash through it. So that's D.
Oh.
Order matters. Yep, same symbols.
We also do AB and also QT.
AD and QT. Yep. But you can't intermix those two. You know what I mean?
Yeah.
Yep. Yep. All right. So back here to angle A. If I'm talking about the geometric angle, I label it angle A. Okay? Now this is an equilateral triangle, which means that it is also equiangular. Okay? So if I am talking about angle A being congruent to angle B, being congruent to angle C. That's what an equilateral triangle has. It has three equal sides. It has three equal angles. If I'm talking about the geometric angles, I have this angle symbol out there. Now that angle symbol is different than a less than symbol. Okay? It doesn't mean that it's less than. It just means that it's an angle. Okay? That's geometric. If I'm talking about the angle measure, let's say that this angle is 60 degrees, because the three angles of a triangle add up to be 180. So if they're all equal, 180 divided by 3 is 60. So if I'm talking about an angle measure, then I put a little lowercase m in front of it. So the measure of angle A would be equal to, the measure of angle B would be equal to, the measure of angle C would be equal to 60 degrees. Okay? If I'm talking about the measure of an angle, that means I'm talking about numbers. Okay? I'm talking about a value. If I'm talking about just the angle, then I'm talking about the geometric shape that is that angle. Okay? These are different. Okay? Now, if I have one angle, like at angle A, at angle B, and angle C, if I only have one angle there, I can use a single letter to describe it, to name it, if you will. Okay? But if I have multiple angles there, like we do here in letter B, again looking at angle A, I've got an angle there, I've got an angle there, I've got an angle there, I've got this angle here, and I've got this angle here, this angle here, and on top of it all, I've got this whole big angle over there. Okay? So there's really 6 angles at angle A. Okay? So I can't use one single solitary letter to describe any of those angles at angle A. I can still use a single letter to describe angle B. I can still use a single letter to describe angle C. I can still use a single letter to describe angle B prime. And I can still use a single letter to describe angle C prime. But at angle A, there's 6 total angles. So I can't do that. So the 2 angles that are equal are this blue one and this green one. Okay? Those are the 2 angles that are equal, and I have to go to the 3-letter name for it. The blue angle is angle BAC. The green angle is angle B prime AC prime. How we 3-letter name an angle is the middle letter is the vertex. Okay? It's the point of the angle. Okay? So that middle letter is the vertex. The other 2 letters are points that are on those rays on the sides of the angle. Okay? And it can be any point as long as it's on that same ray. Okay? So if there's one angle at a point, or at a vertex, you can use a single letter for it. If there's multiple angles, you need to use the 3-letter name for it. Okay? All right. Let's start talking about complementary angles. If you had a highlighter, now would be the time to use it. Okay? Complementary angles are angles that add up to be 90 degrees. Okay? So complementary adds to be 90. It makes a corner, if you will. Okay? Angle plus angle meets 90 degrees. The symbol for a right angle is this box in the corner of an angle. If you see that box in the corner of your angle, that's telling you that that angle is 90 degrees. Those lines are then perpendicular. Okay? So if you see that box, That's there. So we know that these are complementary. Angle ABC and angle CBD are complementary. So here is my ABC, that angle, plus angle CBD are complementary because they add up to be 90 degrees. So if angle CBD is 76 degrees, we need to find the measure of angle ABC. Let's call it X. Well, angle plus angle is 90 degrees in complementary, so X plus 76 would be 90. Yes? So what is X? Subtract 76 from both sides. What do you get? But this is an angle, correct? Okay. So with it being an angle, you add more stuff to it. First thing you add is the degree symbol. Second thing you add to it is you add the name of the angle. Angle ABC is 14 degrees. Now don't get lazy with your degree symbol. Angle ABC is not 140. Okay? Alright? It's 14 degrees. Okay? And that then would be your answer. Without proper labeling and telling me it's in degrees, I will mark things wrong. Okay? Just do stuff right from the start, and then you don't have a problem. Okay? Don't make up your own math rules. Okay? Another special angle is supplementary angles. Supplementary angles add up to be 180 degrees. They make a straight angle. So if you have a line, it's also called a linear pair. When you get into Math 2 next year, you'll call it a linear pair also. Okay? LMN is a straight angle. So it says that LMP is 62 degrees. We want to find the measure of angle PMN. So we'll call that X. We know that it's a straight angle, so that means that X plus 62 is how much? 180. So subtract off 62. X then becomes 118. So the measure of angle PMN is 118 degrees. With me so far? Okay. Next one that we want to talk about is vertical angles. Vertical angles make an X. I know, I wish I could say it, but I wish I would say it makes a V, but vertical angles make an X. So this angle here, we'll use our geometric. This angle is equal to that angle. And this angle here is equal to that angle there. Two intersecting lines make 4 vertical angles. So this angle here would be equal to that one, and this angle here would be equal to that one. Okay? So if, where does it say? If x intersecting if x equals 23 degrees. So this one here is 23 degrees. What is the, give me another angle with its name and its measure. What do you got, Daisy?
Angle CED equals 23 degrees.
Yep, because it's the vertical pair. Angle CEB is equal to 23 degrees because it's the vertical pair. Yes. The two blue angles, though.
Do you need the M?
Oh, did I forget the M? Yep. Because we're talking, yep. Wait a minute. BED, okay. So what is that? 157? Any, is that what you were going to say?
What?
What were you had your hand up also.
Yeah.
What do you mean the other one? AEC. So those two are going to be equal, right? The reason I'm saying that is because I can go like this. Measure angle AEC. Oops. That's ACC. What did you say, Ben? BED?
Yeah,
Bed? Nope. Because we're talking measures.
Oh, yeah.
Yep. Yep.
How do you say that? Does it, if it has the M and the angle, do you just
Measure of angle AEC. Or if we were talking just the angle, then you would just say angle AEC. Yep, you just read it left to right. Now, it could also, the reason I asked you to name it is because we could have also named it angle CEA. With me? Because we're not talking congruency, so order doesn't matter in terms of that one. Okay? So those are vertical ones. Okay? So now what I want you to try right now is I want you to try if this angle is now 54 degrees, you find me the measure of the other 3 angles. Go. So I get measure of angle CEB is 54 degrees. The measure of angle BED is equal to the measure of angle AEC is equal to 126 degrees. Yes? Love it. Okay. So if 2 angles are vertical, then what do we figure out about them? Well, we already found out. Then the angles are congruent. It's a bad E. I don't like it. I don't like it. would those be then? The P word. Not parallel. Perpendicular. Yep, perpendicular lines they would be 90 degrees, and so then the vertical angles would all be 90. Kind of almost how I have it drawn over there on the sideboard. Okay? Ooh, okay. So in a triangle, we'll go up here with it now. What do all of the angles add up to be? How many degrees in a triangle? 180 degrees. Yep. So this would be angle plus angle plus angle is 180 degrees. Okay. Good to know. Okay. So if, I'll just make up a triangle over here on the side, if we've got this angle here is 23 degrees, and this angle here is 78 degrees, what is the measure of this angle over there?
What?
If we've got this scenario,
30. Yes. Or 8.
so what would the equation be that I would set up here? 78 plus 23, I'm color coding because I like to color code, plus x equals how much? 180. Okay? 78 plus 23. 101?
Subtract 101.
79?
Good afternoon, Warriors. Happy spring.
So, on your homework this evening, you can handle the first page. That's just from Unit 6. That's a refresher from Unit 6. On page 2, it's talking about all the different kinds of angles that we talked about today. The only one that we didn't talk about today was letter D, which is an isosceles triangle. If it's an isosceles triangle, sit down. If it's an isosceles triangle, the base angles of the isosceles triangle are equal. Okay? That's a theorem that you'll learn, that the base angles of an isosceles triangle are equal. Okay? Alright? Otherwise, we learned all those different angle pairs. We learned all those based off of that triangle up there. All good to go. Have a good day.